Let's take a look at the slides for section 2.2, comparing sets. In this section, we'll want to determine when sets are equal, know the difference between the relations of subsets and proper subsets, use Venn diagrams to illustrate set relationships, determine the number of subsets of a given set, and distinguish between the ideas of equal and equivalent sets. The definition of equal. Two sets, A and B, are equal if they have exactly the same members. In this case, we write A equals B. If A and B are not equal, we write A does not equal B. So, for example, if we have a set A that's equal to 1, 2, 3, 4, and we have a set B that's equal to 1, 3, 4, 2, then we say that A is equal to B, because every element in the set A is in the set B, and every element in set B is in set A. Definition of a subset. The set A is a subset of the set B if every element of A is also an element of B. We indicate this relationship by writing A is a subset of B. It's a symbol that kind of looks like a C with one underline below. If A is not a subset of B, then we write A is not a subset of B using that C-shaped symbol with the line underneath, but then we slash it out, we cross it out. Now, let's take a look at subsets. So if we had a set A that was, say, the set 1, 3, 5, 7, 9, and we had a set B that was the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then we would write A is a subset of B, because every element in the set A can be found in the set B. The 1 is in the set B, the 3 is in the set B, the 5 is in the set B, the 7 is in the set B, and the 9 is in the set B. We use Venn diagrams to show relationships between sets. A Venn diagram is used to visualize relationships among sets. The definition of a proper subset: the set A is a proper subset of the set B if A is a subset of B, but A is not equal to B. We write this as A is a subset of B, and it looks like a very thinly shaped C as our symbol. So we write this as A is a subset of B using that symbol. If A is not a proper subset of B, then we write, crossing out that symbol, that A is not a subset of B. And this image of a square labeled U with an oval labeled B and a circle labeled A, all nested inside of each other, is representing the concept of a proper subset, where A is completely inside of B and B is completely inside of U. So what we write and what we know is that A is a subset of U. B is also a subset of U, the universal set. A is also a subset of B, but A is not equal to B. So A is a proper subset of B. And we could have an example, right? So if, for example, A were the set 1, 2, and B were the set 1, 2, 3, then A is a subset of B because every element of A can be found in the set B, but A itself is not equal to B. Venn diagrams and proper subsets. Continued. The number of subsets of a set. A set has k elements. A set that has k elements has 2 to the k subsets. How many, for example, how many subsets exist for the given set? A is the set, which for some reason the brackets didn't come up, so I'll just draw them on there. A is the set of the names Bill, Gil, Jill, and Will. And there are 4 elements in this set. K is the number of elements in a set. Two to the K is 2 raised to the power of the number of elements in the set. Here, 2 to the power 4, or 16 subsets. If we wanted to look at an example of a subset here, the book might ask us something like, list all of the 2-element subsets from this set. So, put our brackets back on. Two-element subsets would be Bill and Gil, Bill and Jill, Bill and Will, then we would be done pairing Bill with people. Now we can pair Gil. I'm going to cross Bill off. We can pair Gil with Jill. We can pair Gil with Will. And then Gil has been paired with everyone at least once. And now, lastly, we can pair Jill with Will. And you'll see that Bill's name comes up in 3 groups. Jill's name comes up in 3 groups. Gil's name comes up in 3 groups, and Will's name comes up in 3 groups. We have a total of 1, 2, 3, 4, 5, 6 subsets of size 2. So there are 16 total subsets. There's 6 subsets with 2 elements. Definition of equivalent. Sets A and B are equivalent or in a one-to-one correspondence if the number of elements in A is the number of elements in B. Another way of saying this is that two sets are equivalent if they have the same number of elements. The set 1, 2, 3 and the set containing A, B, C are equivalent because both have 3 members.